This question says the function h of t is equal to negative 0.25 t squared plus 1.7 t plus 12, where h is height in feet, models the height of an angry bird shot into the sky as a function of time in seconds. Use this function to answer the following questions. Round all answer to 2 decimal places. How high above the ground was the bird when it was launched? So when it was initially launched, that has a time of 0. So that is the equivalent of asking us to evaluate h of 0. And so we get negative 0.25 times 0 squared plus 1.7 times 0 plus 12. And when you multiply something by 0, it becomes 0. So the first 2 terms are going to disappear, and we get that h of 0 is equal to 12. And so that's why the initial height of the bird was 12 feet above the ground. The next question says, after how many seconds does the bird reach its highest point? Now, this is going to require us to find the vertex, and there are several different ways that we could go about doing that. One of the ways is by using the formula negative b over 2a. This helps us find the x-coordinate, or in this case the t-coordinate, of the vertex. So negative b over 2a. I'm going to label my a value here, my b value here, and my c value here. So if we were filling in the values of that formula, negative b would be negative 1.7, and then 2 times the a value, which is negative 0.25. And I'm going to pull out my handy dandy calculator. So that's going to be 3.4. So again, this represents the t-coordinate of our vertex. So if I drew a quick little picture here, we know that the initial height is 12, and it looks something like that, and then the bird would hit the ground after some amount of time. So this here is going to be 3.4 seconds. Now, we want to figure out the height of the bird at the highest point. So at the highest point right here, we found that that was 3.4 seconds. And to figure out the height, we just need to plug in 3.4 into our height function. So h of t is equal to, that should be h of 3.4. is going to be equal to negative 0.25 times 3.4 squared plus 1.7 times 3.4 plus 12. Now, I will leave that up to you to throw into your calculator, but if you evaluate it correctly, you should get 14.89. So at the highest point, it has a height of 14.89 feet. The next part of the question asks, after how many seconds does the angry bird hit the ground? So let me draw a picture again since the other picture disappeared. We found that the vertex was at 3.4, 14.89. This is the height, this is the time, and we know that the initial height was 12, and so now we want to find basically this ordered pair right here for when the bird hits the ground. And the way that I'm going to do that in this question is by utilizing the quadratic formula. So in this case, t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and fill in those values. We know that b is 1.7. I'm running out of some space here. Okay, there we go. So 1.7 squared minus 4 times a, which is negative 0.25, times c, which is 12, all over 2 times a. Now, if you throw that into your calculator, you should get two different answers. So one of them is going to be negative 4.31, and the other one is going to be 11.12. Now, the thing that we're measuring or calculating here is an amount of time, and so in the context of this question, we don't really want to be looking at a negative time value. So the answer that we want to look at is the positive time value. So what that means is it's going to take 11.12 seconds for the bird to hit the ground. So 11.12 is the answer for that one. The next question says, if the bird is traveling at 16 feet per second, how far does the angry bird travel before it hits the ground? If the bird is traveling at 16 feet per second, it will travel blank amount of feet before it hits the ground. So the way that we're going to calculate this one, well, first of all, let me fill in that this is 11.2 seconds. And we know that the bird is traveling at a speed of 16 feet per second. So if I multiply 11.12 seconds by 16 feet per 1 second, these seconds will cancel out. And if I multiply 11.12 and 16 together, that is going to give me 177.92 feet. So that's, if this is the speed and this is the time, then if I multiply those two values together, that will give me the distance traveled. So that is what we are looking for, 177.92 feet. Now, the last two questions are asking about the practical range and the practical domain. So let's talk about the domain first. Normally, when we're dealing with quadratic functions, the domain is all real numbers. However, it doesn't make sense in the context of this question to talk about negative time, and it also doesn't really make sense, or it doesn't matter talking about the time after the bird hits the ground, because the bird is not moving anymore after that. And so if we're thinking about the domain, remember that's the input values. So we're basically starting here and ending here. And so we're going to have 0, 11.12 as our domain. And then for our range, we are looking at the output values or the vertical values. So that's basically starting here when the bird hits the ground, and it's going to go all the way up to the highest value of the height of the bird. So the range, or the practical range, is going to be 0 to 14.89. And that concludes this question.